has been technology making it much better today, so thank you all for your patience. Can't hear you. Better? Oh, there we are. Okay. So, all right. There may be another technical hiccup we can have. I can't think of what it would be off the top of my head, but basically the end result is that I'll probably skip a little bit here and there and just talk real fast to make up. So I'm Chandler Howell. I work for Nexum. We're a network and security resellers and consultants based out of Chicago, covered all over the basically everything east of the Mississippi. And so what I want to do is I want to talk about, IoT. It's getting more and more and more press and coverage and mind share. And so kind of get us some definitions, talk about, kind of why things are currently such a mess, get into some of the implications of this, provide a real simple model for thinking about failure modes that, may cause you to consider some things that aren't fitting into a lot of the conversations that I've been participating in about IoT, run very, very quickly through, all the things that have been at this point well documented to kind of suck at this stuff, and then get into what we can be doing about it to address this, ideally far up the line into the development process, but also as these things start showing up in our worlds and we have to figure out what to do about them. So starting with the Internet of Things, I like the Gartner definition, and these are smart devices, as we call them. So it's take something that you already had, put an IP on it, put some management on it, put some telemetry on it, and call it IoT. I differentiate this a little bit from the SPIME, which was what Bruce Sterling proposed back, about 10 years ago, the idea of objects that were spatially and temporally aware. And it seems like that's fallen more down into things like, RFIDs that might have some onboard capability to keep up with where they're at and what they're doing. And those are going to be pretty much out of scope for this. First thing we need to know is that, this thing's massive. It's getting massiver. I decided that that should be a word, so it now is. Once again, they're talking 20 billion devices in 2020. That's a heck of a lot. And, and where it's mostly seems to be hitting right now is residential. So this was Praetorian down in Austin, got a drone, built an IoT sniffer, started flying it around, and what they discovered was that it's like 80% residential, which is, of course, a polite way of saying will never be patched or maintained. So where this gets us is that we've now got all these devices out there, and security is not a concern. So what everybody is worried about is, how do I keep my unit cost down? And so they're doing things like using little 8-bit processors that can't do any sort of meaningful crypto because it costs $5 to put one of those on a board, whereas it costs $25 to put something on a board that's going to actually do meaningful crypto. They're trying to get to market because right now it's a land grab for market share, for mind share. And, it doesn't matter if you've got a better product if someone else has already shipped it and they're now the de facto leader because, they'll maybe roll this stuff in version 2.0. Meanwhile, you're out of business. And once again, where they're committing engineering resources is around features and functionality. And in a lot of these cases, security is actually viewed as a detriment because it's going to make things like integration more difficult. So, what we've got is cost, time to market, features, functionality. What we don't have as a result is security, maintainability, or any consideration whatsoever about the longevity of these devices. And this is where stuff starts to get really interesting because these life cycles are totally mismatched. I mean, most people were replacing their phones every 12 to 18 months. PCs, 3 to maybe 5 years. Network gear is 6 to 8 tops. But you go out and you buy a new refrigerator, your new smart refrigerator, every 15 years probably, maybe longer if the thing doesn't break. Water heaters, HVAC, stuff like that in your home. These are all, 12 to 13-year devices. You get out into the industrial world, this stuff is literally designed to outlive you. Things like locomotives, big diesel engines, things like that, they have a planned service life of 50 years or more. You go, so I take Metro, the commuter rail to work, and I look at the train cars, it's got a manufactured plate. They got stuff from the 60s. It's still out there rolling today. And the only things that they replace on those are the parts that break and just absolutely have to be refreshed. So then it gets worse because we come back to IT. And IT is not able to handle the volume of these devices. We've got, I mean, basically this is what's going to drive us all to IP6 eventually. You know, someone last night said to me as we were talking about this, you know, everything will just live behind a NAT. And it's like, that's great, but that kind of creates as many problems as it solves for lots of reasons. You got to keep up with these things. So you got to find out when they're coming into your environment. I mean, that's easy-ish in your house when, you know, you're simultaneously the IT person, the procurement person, and everything else. But you go out into the business, and how do you know what devices the facilities guys are putting in to better manage their buildings? You know, if you're in some sort of like LEED Gold building, there's all kinds of IP-enabled stuff in there that you're probably not aware of, and they may not even appreciate how connected it is. You're logging and monitoring. So some of these things create massive amounts of telemetry. Are you licensed for this stuff into, you know, your log management solution? You know, Splunk is great, but it's not cheap, and it's, you know, it's by the meg, or by the gig, or by the terabyte. Can you handle this stuff from an incident response perspective? As you think about, you know, detection. And so now we get into something like, okay, what do we find? We've got an issue with a light bulb. Which one? So go out and figure out which light bulb it is. Hope it's not obvious because they're, you know, all blinking different colors. Compliance becomes another big one. As these devices are generating data, are they producing information that could be used in violation of your privacy policies? Is that considered a feature or a detriment of that device? Do you need to retain this data? If you're getting telemetry off of systems that exist in a plant somewhere, say, or systems coming off of, you know, your trucks out rolling in the field, what do you need to do with those? You know, can your standards handle this stuff, period? You know, do you have standards in place for things like Zigbee? You know, insurance is, that's another fun one where this stuff is really starting to collide, because what you'll find is, Chris talked this morning about get a cyber insurance policy. Now try and get them to pay off on an incident. So, you know, they will come with all sorts of reasons. It's like, I'm from Texas, and down in Houston, everybody used to have hurricane policies for hurricanes. Well, then after Rita, they figured out that they could disallow everyone's claims by saying that wasn't hurricane damage, that was wind-driven rain damage. So everyone's got to get a wind-driven rain policy. And then they'd say, well, no, that was caused by flooding. Did you have flood insurance? So insurance guys are really, really good at figuring out how to not let themselves be on the hook for this stuff. And the other big place where the physical is starting to really collide with the virtual world is around lawsuits. And what we're now seeing is that lawsuits being certified to proceed for liability on software. Most significantly, I think, was the Toyota class action suit around defective software for their accelerators. So that's going to take a few years to play out. But I think the ultimate result of that may be that at least some set of software is now going to be covered by liability requirements. So then, how do these things fail? And I was thinking about this and from a kind of a little bit of very, very lightweight threat modeling. And I said they can basically fail in one of three ways at that first level. They can get broken. So someone breaks in, they hack your toaster, and they nuke it. Maybe they use it to burn your house down. They can be leveraged. So this is where we get into things like the botnet of refrigerators and coffee makers. They can be used as a beachhead because they might be very difficult to find. If they're spewing telemetry out to a cloud somewhere, then it may be very difficult to recognize that they're doing something interesting and malicious. And most significantly, they can get exploited. And this is the one that I don't think nearly enough attention is being paid to. And this is really where what we start to see is, you know, these things are being used against you. There's an old saying, you know, if you're not the customer, you're the product being sold. Increasingly, you're going to find that you're both. And this is where we see things like Samsung and LG smart TVs. You can go out and Google for LG smart ad program. And, you know, they're upfront about it. If you buy their smart TV and you use the smart features on it, they're going to collect information and use it to sell targeted advertising towards you. So, you know, and expect this is the new normal. Then we get into our parade of horrors, right? All the stuff that we know fails. There's not a single new or, frankly, particularly interesting thing in here. This is just people doing software and product security badly. A lot of these things, like I said, they skimp on crypto, or they just don't use it. They assume that, oh, we're going to use a binary format on the wire, and therefore no one will look at it. A little security about security. Yeah, right. They're not worrying about authentication. They are running these things in a single user mode, so everything leads to a complete compromise of the device. They don't use signed images. In a lot of cases, they actually fail open, and they call that ease of integration. So just this stuff, it kind of drives me nuts because it gets in your environment, and it's going to be there for 5, 10, 15, 20, 50 years, and you're just stuck with it. And of course, it's not it's not the facilities guy's fault that he bought crappy stuff. It's your fault that you weren't able to secure it. So, we can run down the list, right? Consumer goods, fridges, light bulbs. Light bulbs are fun to pick on. I don't know why. But smartwatches. I don't know how many people saw some guys figured out a proof of concept for a keylogger on the Apple Watch. So they use the gyro and the 3D detection, sort out where your hand's moving on the keyboard, and then they can infer the rest for what your other hand is doing. Medical devices. These things scare the hell out of me. I used to work in the medical device industry, and they weren't just happy if it worked at all. They were thrilled if it worked at all. So and they don't seem to be doing any better at it now that they're putting Wi-Fi connections on and IP addresses. Cars, everybody's seen all this. Infrastructure. This one bothers me a lot because these things are, once again, big, long life cycle. Smart electric meter. Found out I'm getting a smart electric meter this week. So I was like, great. There was a village, suburb out on the edge of Chicago. They put in smart water meters. Well, they didn't work for crap. They had a problem called spinning, which basically meant that they would spin up, registering a rate, and then they would never dial back down as the water consumption fell off, so massively overcharging them for their bills. Turns out that this was a design defect in the smart meter. So they took it back to the company that made them. And you know what that company did? They just spun that division off into a separate business and bankrupted it. So now the village is on the hook for $2 million to replace their defective meters. Once again, these are the sorts of strategies I think we will see as the marketplace starts to mature and shake out, is that these guys, they don't care about us. Behavior like that makes it very, very clear. Traffic lights, bad. Industrial control systems. This was actually where I first encountered what we now think of as IoT, was trying to secure factories that were getting crushed by worms and viruses back 10 years or so ago. And so what we wound up doing was basically, you lock them down, you firewall them off, you segment the environment such that the network boundaries match the scope of control for risk boundaries, meaning that the only people who can make a decision that might put that network at risk are the people who are going to be on the hook if something goes south. And what we discovered was that when we first just blocked it all off, we still had problems. They'd bring laptops into the factory, they'd plug them in, those would infect things. Why? Because there were 50 lines in this plant and anyone could approve it. Once we locked it down to just that line, so that only the manager of that line could approve a laptop to go in and take his line down, not only did the number of laptops need to go into the factory, go through the floor, but the number of incidents did as well. And so we were unable to secure the devices. There was stuff running Windows 3.1, Windows 2000, OS 2, a lot of OS 2 in that plant, chip shooters. And so we get into this, and so the point of that is that we don't have to just give up. It's not an option anyway. This is kind of like an ization. I was trying to come up with like an IoTization. It's like globalization. You don't fight it, you just deal with it. So the first thing is, and I think this is key, don't panic. The knee-jerk response from some folks I've talked to is it's like, no, just keep it out. And that's not going to work. There's too many people making too many compelling business cases that they have to have these things. And so what it comes down to is the people who figure out how to manage the risk associated with them effectively are going to get a competitive advantage in their market, and thus they're going to grow and win. So when these things are coming in, think of them in terms of failure modes. What is your concern over having this thing get broken or get used to go after something else? Is it, could it be a beachhead? Do you need to worry about that? How do you protect the rest of your environment from that? Is it going to be used against you in some other mechanism that you may not even thought of, especially with that data telemetry going out to the cloud. But once again, I mean, when you saw that list of fail, there was nothing new in there. We didn't have to make up any terms to list off all the bad things that are happening with these devices. But what you do need to realize is that we will see novel attacks around them. We'll see people coming up with new and different ways to get up to no good that we have not seen before, especially as we look at that intersection of physical and virtual. So once again, assess the risk, align the trust and risk boundaries. So this is where we get into things like segmentation, possibly even micro-segmentation in some scenarios. And this is going to be a lot of work, especially if you don't have good mechanisms for figuring out what's on your network. Because, one of the things is this stuff's going to just start showing up. It's going to be coming in through the back door. You're not going to know about it. You need to be architecting for these things to be insecure. Because, today's latest and greatest is tomorrow's old, outdated, insecure piece of crap. As these markets start to mature, we're starting to see standards come out and be adopted. Insist on those standards. This is going to keep you away from, probably questionable to sketchy bridge code and integration. This is going to simplify things in terms of figuring out what the heck is going on. And then along with this is that, figure out how, or I say don't forget how to operate without these things in a lot of cases. Work if you have it with your disaster recovery or business continuity teams. This is kind of their full-time job to think about it. And so, they'll care too, which is the other nice piece of it, is that, they want to know this stuff just as much as you do, although maybe not for the exact same set of reasons. Once again, do everything you already knew how to do. And don't act like these things are special, delicate snowflakes. They're not magic. They may seem kind of magical and tend to be very tiny, but, in general, everything you do for traditional IT, traditional network devices, you're going to do for these as well. And then you're also going to, as we start to see standards bodies emerge, working groups emerge, support those. If you are working with vendors, encourage them to work with these groups and comply with what's coming out. Hold this line. Make sure that the cost of everything that we're having to do as security people gets accounted for in these things, because a lot of times if you sit down, it's like Cisco is pushing smart lighting driven off of PoE ports. Why? Because they're looking for any reason to sell switch ports. But what they never mention in any of this is the fact that there's still IT that goes with it, and there is a cost per switch port, and just because it's not, a Windows or Mac or a Linux machine doesn't mean that it's magically free to have that thing out running on your network. And that is it. Thank you for your patience, and thank you for your time.